Hello everyone, Debabrata once again, and today I'm planning to take a class on the matrix. So we have already done the single dimension array. So today I'm planning to take on the double dimension array. So let me explain what is double dimension array and what is the difference. Will it be hard or will it be easier one? So let me discuss all those things. But as a prerequisite, I can say like, okay, you can it will be very best if you are following all of the classes, all of the previous classes, and then come to this class. If not, I think if you have some idea on for loop, that will be enough. You do not need to go through the single dimension array because matrix it can be achieved without knowing single dimension array as well. So just a basic knowledge of the for loop, and if you are following my playlist, then it's fine. And obviously at the end you have to practice all the things. So you can put my screen on hold and you can practice all the things. So first let me discuss what does it mean by double dimension array, or it is pretty common program in double dimension array, like it might be asked like enter 3 rows, 4 columns and print them back, something like that. So let me first go to some online compiler, so you can write your program in any compiler. So let me choose the online one, so it will be easier for me to open without installation or anything. So double dimension array means it will have few rows and few columns. It might look like, suppose if it is asking for 3 row and 4 column, it will look like something like this. 3 rows you can see, and here if I draw, my drawing is not that good, but still at least you can understand 4 columns. So row means if you are confused with what is row, what is column, then I will say like you can take a resemble, you can put a similarity of like arrow. An arrow is the horizontal one. So rows are horizontal actually. So if I say what is row here, so we can say this is row number 0. The second one, it is row number 1. So row or column both starts from 0, and it is row number 2. So somehow if I can write it here, so I can write, so the first one will be called as row 0. So we have 3 rows here. Okay, row means the horizontal line. So it is row 1, and the last one will be called as a row 2. So something like that. So now if I just check the column, what is column? Column, as the name suggests, it means the vertical one. So what does that mean? Vertical means this one is a column. Okay. So it will be called as a column 0. Here it will be called as a column 1. This one will be called as a column 2, and this will be called as a column 3. So 4 columns will be 0 to 3. 3 rows will be 0 to 2. So I think it is clear. So column, if you forget the what is column, column is a vertical one. It you can put a similarities with column or a pillar of a building. So column or pillar of a building is the vertical thing. So you can easily remember using those two examples. Row means like an arrow, a horizontal, and column means the column or the pillar of a house or of a building. So that is the vertical one. So you can think about that. So now if I just write the gist what we have just discussed, so the first one will be called as a column 0. The next one will be called as a column 1. So if you have 4 columns, it starts from 0, and obviously it will be ended at 3. So if you have C number of columns, say C number of columns, that means the column numbers will be 0 to C minus 1. So 1 less. So a similar thing actually in array, in a matrix, in string, everything starts from 0. In programming language, C programming language, everything starts from 0. So same thing happens for the row as well. So another thing you need to remember, you have to always mention row first then you have to mention column. So that is the convention. So always you have to mention row first, then column. So if I say like, what is the address of this cell I have marked? So this cell will be called as a row 1, as you can see, column 1. So I can mention that like A11, something like that. So let me write that inside the box itself. So it will be called as a A11. Got it? So if I take some other examples as well. So suppose if I want to get the address of this box, so it will be like row 1 and column 3. That means this box will be termed as A of 1 and 3. First, 1 will be mentioned as the row comes first, then column. So A13, something like that. If I take another example, like suppose I want to get the address of this cell. So the address of this cell will be, you can see, row is 2 and column is 1. So it will be termed as A, 2 and 1. Okay. So something like that. So just you have to remember column and row both starts from 0. So if you have C columns, means 4 columns, it will be 0 to 3, means C minus 1. Same for 3 rows, it will be 0 to 2, means R minus 1 rows, 0 to R minus 1. So now, if I want to write a program with that, means what was asked in the slide, 3 rows and 4 columns. So let me write a program first. So I will define an array and matrix, sorry, it is also an array, it is a double dimension array. So you can define it like int A. It has say like 3 rows and 4 columns, I guess. Let me check once again. 3 rows, 4 columns. So you have to define that first. For definitions, you have to write 3 rows, and here you can write 4 columns. So it is just the declaration. You are declaring the matrix on the first line. So it is 3 rows and 4 columns. So you can see you have, it is being called double dimension because it has 2 dimensions. So one length and another is width. So this denotes row number and the next one denotes column. So row number always come first, then column. So 3 and 4 means 3 rows, 4 columns. Okay. So now if I want to print all the combinations, suppose I equals to 0, I less than 3, suppose obviously less than, or I can write less than equals to 2, something like that. I equals to I plus 1. Similarly, I can write j equals to 0, j less than equals to 3, and j equals to j plus 1. And if I print like printf, suppose what can I write, percentage d and percentage d and a space, then so I and j, if I simply print it is a program of for loop, and after each line if I put a enter, printf, just putting a enter. So if I run that, it will generate all the combination of 0 and means all the combinations of row and column just by using for loop. I have not used any matrix. So let me delete this thing as well. If I run that, I have not used any array or anything. I am just using all the combination. I'm just trying to generate all the combination of I and j. So I is iterating from simply 0 to 2 and j is iterating from 0 to 3. So then you can see I got all the combination. So this combination actually denotes the value of the cell. So here it will be 0, 0. If I take a look in the picture, so it will be 0, 1. So I'm just generating all the combination using for loop. And believe me, matrix programs are very easy than the array programs, because this loop that I have just written, it will be used in almost 95% cases, or at least to be on a safer side, I can say like, okay, it will be used on almost 90% of programs. So at the starting itself, I have generated that file, that for loop, to generate all the combinations. So the combinations are something that you can see in my screen. So in the picture as well, even in the output window out as well. So these are the combinations. I have not used any array, any matrix, anything in this program. It is a simple for loop program. You can see it is not a program of array and matrix. It is a simple for loop program where I have generated all the combination of I and j. Simply all the combination of I and j. And I hope you have that knowledge of for loop. And everything else depends on the for loop. So again, for loop will control everything here, but it is simpler because it is not like array chapter. If you are starting fresh from matrix, it will be okay. You do not need a knowledge of array. And here in matrix chapter, these two loops will be used in 90% programs. 10% programs will be something different. But today, whatever we will do, probably all of them will be depending on this for loop. So this for loop is simpler and easier to use. So you can see now if I can generate all the combination of I and j from I ranging from 0 to 2 and j ranging from 0 to 3, then obviously I can take some input as well from the user. So I can print something like printf. I can say something like enter elements or something. I can say. And okay, now let me introduce the matrix, that is 3 and 4 or double dimension array. Both the name are same. So here, rather printing all those combination, I will just take an input into those places. So into aij on that position means it will generate, these two for loop will generate all the combinations of 0, 1, 2, 3 on those things. All the places it will generate these two for loops. If I get all the places of the matrix, so how means why shouldn't I take an input into those places? So I'm just writing a scanf to take input on those places. That's all. So I can get all the places, I can generate all the places of the matrix. So I am using that for loop to take the input as well. If I can take the input, I can print the output as well, because I can generate all the places of the matrix. So I can using the same loop, because this loop is very efficient. Believe me, this loop is very efficient, and this loop is able to print all the places of the matrix. So using that same loop, I have already told you, like this loop will be used in 90% cases, even more than that. So if I can use that loop to print, to take input of all the elements, so why shouldn't I use the same loop for printing purpose as well? Because this loop is able to generate all the places of the matrix. So let me now use the same loop for printing the elements. That's all. So okay, we do not need to put an enter here, just it will be simply a scanf, and here it will print, I will print all the elements, and after each line, when I will be changed, I will change the line. I will just hit a enter. So let me show you how it behaves. So enter elements. So I will say like, okay, enter elements 10, 20, 30, suppose 35, 40, 50, 60, 65, 70, 80, 90, and 95. If I run that, so you can see the elements are 10, 20, 30, 35, 40, 50, 60, 65, kind of that. Let me put a enter here. Let me put a enter here just to give a new line, just to print everything in a new line. So you can input some values, either hitting enter or pressing tab or pressing space as well. So I can input the values in a good manner as well. So it doesn't require any extra line to write in the program. I can simply write in this way. So either you can use space, you can use enter, you can use anything. So let me use that. So now 40, 50, 60, and 65. Now 70, 80, 90, and 95. You can use anything. Either you can hit all the enters or you can put space and enter. So it will look like matrix. So computer do not understand what is matrix. So I have just taken the values in that manner, and I am just printing them in that manner. When I equals to 0, all of them are getting printed in the same line. When the value of I will be changed, I will be hitting an enter. So it looks like a matrix. Okay, and obviously this loop is going to help me because this loop is able to generate all the places of the matrix. So I will always use this loop to traverse through the matrix, because if I use this loop, I can visit all the places. In simple word, this loop helps me to visit all the places of the matrix. So if I use that loop, I can visit all the places. And obviously, if I can visit all the places, I can take input, I can print them, I can calculate sum, I can calculate maximum, anything I can do. Okay, so this loop, we can call it as a, let me delete this thing then. So this loop, I can call it like 90% usage loop. And it helps to visit all the places of the matrix. Okay, so that is the gist. It helps to visit all the places. So if I can visit, I can take input, I can print the data, I can compare, I can get the sum, I can calculate anything. So everything I can do if I can visit all the places. So you can see probably today all the programs, I don't know what is there in the slide. So today probably we can solve all the programs using these two loops. Okay. So now anyone might say like, okay, 3 and 4 is okay. But what about the other dimensions? So suppose users want to input something. It might be 5 rows, 6 columns, or 5 rows, 3 columns, anything. So what will be your program looks like at that time? So let me show you. So let me introduce RNC. And here I can write something like, okay, here I can put like something like 50 and 50. Now anyone can say like, okay, I can put RNC here. Some of compilers support that. Do not go for that, because the most of the compilers doesn't support RNC. If I write RNC here, most of the compilers doesn't support that. Okay, so it is preferred to put 50 and 50 or any value. Now anyone might say like, okay, if I give 51, what will happen? If I enter 100, what will happen? Then obviously we cannot solve that for the time being. But yeah, later we will know dynamic memory allocation, and at that time we can solve this type of issues. But for the time being, if I write enter the number of rows, it has to be, we have to consider the number of rows should be lesser than 50. If you think it will be huge, take 100 and 100, no issue. Okay, so for the time being, then our row should be lesser than equals to 100. We cannot write something like RNC, ARNC for the time being. Some, again, I'm saying some of the compilers will support that thing, like if I write ARC, but most of the compilers do not support that. So if you are thinking like, okay, this compiler is running, at the time, when time comes, at the time of interview or the exam, you might face some trouble. So it is suggested just to use it in this way. So it is a drawback of array, but there is some way to solve that thing as well. So yeah, so after taking R and C, I can put it here like 0 to R minus 1. So the row and the column will be changed like this in the for loop, and the column will not be 3 anymore. It will be C minus 1. Obviously it is understandable, because if we are running with 4 columns, we are writing 3 here in this place. Now if we are working with C number of columns, it will be C minus 1, obviously, because it is starting from 0. The same thing I will do it here as well. So it will be R minus 1. So now it becomes more general, and now this loop is more stronger, and we can use this loop anywhere. Believe me, we can use this loop anywhere right now. So let me run this program once again. So enter the number of rows. Suppose I want to work with 4 rows and 5 columns, and now the elements, I can input something like 10, 20, 30, 40, 50. After that 60, 70, 80, 90, and 100, say. Enter 11, 22, 33, 44, 55. Some normal values I'm giving that is easily trackable. Okay, sorry. Yeah, 99, suppose. After that, what can I write? 23 something. Okay, yeah, okay, 4 rows. Yeah, it is done. 4 rows, 5 columns, you can see. Either you can input using spaces, either you can input using pressing enter or something. But yeah, if I give a combination of spaces and enter, that looks good actually. So that is the way to go with a dynamic matrix. So if I go to the slide, probably the next question will be something like, what is double dimension? That we know currently. What is row and column? That also we know. So suppose it is asking for enter R number of rows and C number of columns. We have just done that. So what is row? What is column? We know now. So that is the basic structure of the matrix. Okay. So now it become dynamic, but again, I'm saying just for a reminder, some people do things like int a, r, and c. They write the program like int a, r, and c. It is not allowed in the C language. So probably some of the compilers allow that in their part, but it is not general. You might face some sudden problem. If you are habituated with this thing, so you might face some problem at the time of some practical exam or at the time of interview compilers, the company compilers. So it is suggested just write some static values like 100 or 50 and work with this thing. So obviously it is a disadvantage of C, but yeah, later we will overcome that. So now today we are going to learn 3 quick topics, nothing major because the for loops will be unchanged. So the first topic will be the basic matrix operation. So as I have described, all of these things can be achieved by using the same loop. So I will not change the loop. Let's see. So it is saying enter elements and print the sum. So to get the sum, what will I do? So I will just copy this 2 loops. Sorry, first I will take the input. Yeah, here I'm taking the input. I can put some comments as well. So here it is being used for taking for input. Here it is output. So in this program, we do not need the output of this uh, for loop. So let me delete that. Let me take a backup of this somewhere. Yeah, let me take the backup. So, but I need the for loop, the same for loop. Let me copy and paste. And here I will calculate the sum. Let me write calculate. So here what I will do, int sum, if you can remember the 3-step rule, or if you are the new. So if we can print something by visiting all the places, we can put that inside sum as well. So let me put the thing into the sum. Again, to calculate the sum, we have to visit all the places. So we are doing the same. We are visiting all the places, and after that we are printing the sum is percentage t. We have calculated the sum, and after that we are printing the sum. You can see, and using the same loop by visiting all the rows and all the columns one by one. These 2 for loops are efficient to generate all the places of the matrix, and it is dynamic now. So now if I can write like, okay, 3 rows, 4 columns, suppose let me insert some values 13, 20, 30, 35, 40, 50, 60, 65, 70, 80, 90, and 95. So the sum is 645. Probably I am not that good in mathematics, but you can calculate, you can hold the screen and you can calculate in calculator. So probably it will be fine because we have not done any major mistakes. So these 2 for loops again and again and again, I'm saying these 2 for loops are very useful. If you are not able to understand that what I'm doing here with these 2 for loops, just I will request you to just go through from the starting once again, because this is the loop that we are going to use in 90% cases. And that's why matrix is very easier to use. At least it is easier than array programs itself. Okay, so that's the thing. So same, in the similar way, using the same loop, we can print the max as well. So to print the max, what I will do, I will simply write max, and max, I can take the first element as the maximum, and I will traverse through the matrix. I will traverse through all the places of the matrix, and I will access all of them, all the elements. And if any elements is greater than max, I will put that element as max. The simple rule. If you know the for loop, we do the same thing in the for loop chapters as well. So we will just, if any elements is greater than max, I will put max equals to AIT. And you can still see I'm not changing the loops. Scanf loop is same here as well. I'm using the same loop. Okay, because by writing this loop, I can visit all the places of the matrix. And for comparison, I need to visit all the places. So I'm not going to change the for loops. And now here I can write the max is something. So if I run, so again, I can play with probably 3 rows and 2 columns, suppose. So 3 rows is suppose 10, 20, 2 columns only. So I'm hitting an enter after writing 20. So here 30 and 40, suppose. Here I'm writing 5 and 15. 3 rows and 2 columns. Yeah, done. So you can see the max is 40. Yep, that is the result. Okay. So I'm not changing the loop. Okay. So now if I check enter elements and print row wise max. So if I want to get the row wise max, means in the first row, the maximum is 20. On the second row, maximum is 40. On the third row, maximum is 15. If I want to get in that way, simply I will put this max statement inside the for loop. In each row, means in the ith row, the 0th value, means 0th column, the first value in the row will be declared as a max one. And after that, I will compare that with all other elements. And after that, I will going to print the max in each row itself. So I can write something. The max is something in row 0. So I can write it is. So first, I will be 0. So we will be in the 0th row. And the maximum element will be A00. That is the first one of the matrix. Suppose we are dealing with a matrix like, suppose 10, 20, 30, 35, say. Then 40, 50. I'm taking the normal values. I'm not taking any absurd values or any complicated values. I'm taking just easier values just to remember easily. So it is a 00 element. Okay, when we are dealing with I equals to 0. So I'm taking 10 as a max, and after that I'm comparing all of them. And at the end, when this loop will be ended, the for loop of j will be ended, I'll be printing the maximum as 35. After that, I'll be starting with this one. So max will be A10. The value of I will be 1 at that time. So again, I'll be iterating the for loop, and I will be comparing all the values of that row when I equals to 1. And at the end, I will print the maximum one. Something like that. Let me run this code. And let me write the values in some haphazard way. Suppose 10, 35, 20, 30, something like that. 40, 55, 60, 65. Then 95, 90, 80, 70, something like that. 3 row, 4 columns. You can see the max is 35 in row 0. The max is 65 in row 1. The max is 95 in row 2. We do not need a max of the maximum of the whole matrix. I put the max inside the loop of I, because loop of I is denoting the row. So first it will be row 0, then row 1, then row 2. Accordingly, I am considering the max for each row. You can see in the first row, the max will be A00, the first value. In the next, when I equals to 1, the first value will be A10. After that, max will be A20. And after that, I'll be comparing all other values of that row. And at the end, I will print the max inside the for loop of I, so that individual max will be printed for each row. Okay, the last example, we print the max outside of the loop, so that we got only one max. But here I will print that inside the loop of I, because it was required to print max for each row. And that's why we did that. If you are not able to understand this, just let me know in the comment section, or just you can contact me as well. Probably you have my email ID. If you are following the classes, if you are following the exercise, probably you have that. So otherwise, yeah, comment section is always open. And if we are doing any offline classes, you can tell me the same thing there as well. You can mark this point. So topic 2 now. So we have seen on the topic 1, I have used the same for loop in every parts. So in every programs we have used, in every parts of the program, like taking the input, comparing or giving the output, everywhere I have used those two for loops. And now in the topic 2, it is asking for store matrix elements into an array. Suppose it is being asked like we have to store all the matrix elements into an 1D array. We will try to find the relation between 2D array and 1D array. So now what I need to do? First, I will create an array, a single dimension array now. So I will create an array called ERR something, and it will be 100, say, just arbitrary value. So again, first I will be taking the input. After that, I will be storing values into 1D array. What I will do in this case, I will first write something called in position equals to 0. And after that, I will be iterating the same loop to access all the elements of the matrix. And what I will do, this loop will be same, okay, to access all the elements of the matrix. So now here I will write ERR pause. Into the 0 position, I will put the first value of the matrix, Aij. And after that, each time I will do pause equals to pause plus 1. Again, in case of matrix, I am using the same loop. You can see I am accessing all the elements and I'm putting them inside the array. So pause is starting from 0 and every time it is increasing. So the first matrix element will be inserted into ARR 0. After that, the next element will be stored in ARR 1 because pause is increasing every time. After that, the next element, whatever it is coming from the matrix from anywhere, it will be stored into ARR 2 because pause is increasing every time. And that is the way to store the elements. So if I have some matrix like this, suppose, let me delete all those maximum things. Now, if we have something like this, or the structure can be anything, by using those two loops, I am accessing all the places. So it might be 3 by 4, it might be 4 by 3, but those two loops are very efficient. It will help me to visit all the places irrespective of the size. The size can be 3 by 4 or 4 by 3 or 2 by 3, anything. So whenever I'm getting those elements one by one, I'm just trying to put them inside an array. Like first element n will be there. So pause, the default value of the pause was 0 at first. And after that, pause will be plus plus. And next value, I will enter it here. Again, pause will be plus plus. Next value, I'll be entering here. So something like that. So again, if I do pause will be plus plus, I'll be entering 35, something like that. Pause will be plus plus, the same thing. Okay. So 40, then 50, then 60, then 65, everything will be copied, 70, 80, 90. Okay, let me make it large. So 90 and pause will be plus plus. Next time it will be like 95 will be inserted here and pause will be plus plus. Again, those two lines, I mean, ARR pause equals to the matrix element and pause equals to plus 1. So last value of pause will be here. Means pause, I will enter a 95 into ARR pause, and after that pause will be incremented. So pause will be lying somewhere here. So if I want to see the array, I have to print it from 0 to pause minus 1. And that is an important lesson. If you know the use of single dimension array, if you have done the chapter of array already, then it will be easier for you to understand. We have done a couple of programs of array like this. But if you are directly jumping into the matrix and if you are weak in array, suppose anyhow, so you can find the logic like this. So every time we are storing the value into the pause position, and after that the variable pause will be incrementing, so that last time it will also increment into some position. If I want to get the values, I have to write like 0 to pause minus 1. So if I want to print all the single dimension array elements, means I want to print 1D array printing. Suppose if I want to do that, I have to use a simple loop where I equals to starting from 0, I less than, this loop is not related to the matrix. This loop is related to the array. So it will look like, it looks different. Okay. So I equals to I plus 1. Either you can write less than pause or you can write equals to pos minus 1. Both of them mean the same thing. So printf percentage d and space. That's all I guess. Sorry, just let me write it. Percentage d space. And I will write AI. Sorry, not AI, ARR. ARR means the array. And I can print something as well, like the single dimension array is. Let me run. Let me change the format. Suppose now I want to work with 4 rows and 3 columns. So 3 columns means 10, 20, 30. Suppose after that 40, 50, 60. After that 70, 80, 90. And after that 11, 20 to 33. So 4 rows and 3 columns. So if I enter, you can see all of them are getting stored in the array successfully in a linear format. So that is being called as a single dimension array. The chapter we have already solved previous to these classes, and it is double dimension array. We have 2 dimension. I'm not that good in science subjects. I was a student of science subject, but I really didn't like them. My favorite subject was geography, but yeah, for this society, eventually I couldn't take that because you know the reasons. If you do not take science subject, you would not be considered like a good student. So due to those things, I have to take the science subject somehow. So again, so probably you know the meaning of this question. What is double dimension now? And if I stored them into single dimension, how we have stored that, you have checked. So again, the same loop to access matrix elements. All right. So probably if you are getting this 90% uses loop, I think you are feeling a bit relaxed how to access the places of matrix. It is pretty easier than the array programs. So now if anyone asks like, okay, split the elements into 2 different even and odd arrays. So what to do? Obviously, simply I will take 2 different arrays, name even and odd. Let me do that. It is very easy. Let me take an array like even. And after that, let me take an array called odd. And now, first I will take an input of matrix. And after that, I will be splitting that. Let me write the splitting calculation, splitting into even and odd. Obviously, I have to take 2 positions, position 1, or I can take like EP for even position, and another one is OP for the odd position. The same thing I will do. I will access all the elements of the matrix. And now this time, I will just check first if Aij is even, then only I will put the value inside the even array. So I will write even EP equals to Aij. And the same thing, EP will be EP plus 1. So position is called even position now. The same approach, EP will be EP plus 1. So I will segregate them into if and else. The same program, the same lines, the position will be plus plus. So the name of the position is currently EP. Previously it was pos. So now if the element is odd, I will put like odd OP. The name of the array is odd now. So in OP position, I will put Aij, the matrix element. And OP equals to OP plus 1. Matrix is very easy, you can see. We can access the matrix just by using these 2 loops. These 2 loops will help us to visit all the places of the matrix, and rest of the things are very easy. So now if I want to print the array like previous, so I can write something like the even array is, and I will print it until EP minus 1. So previously it was position, now it will be EP1. And the name of the array is no more ARR, it is even. So that's a simple thing. Let me print the odd array as well in the similar way. If I write odd array, and the position of the odd array is OP, it is not EP, okay, and the name of the array is ODD. And I think that's all. So let me write the program. Let me go back to the 3 row and 4 column. Suppose 10, 20, 30, and 35, 40, 50, 60, and 65, 70, 80, and 90, and 95. Just few normal values. You can put any values. Values doesn't matter. You can see the even array is 10, 20, 30, 40, 50, 60, 70, 80, 90. And the odd array is 35, 65, 95. So probably I have to give, I have to hit an enter before printing this. And if I do that, it will be printed in a good format. But answer is correct. This is the even array and this is the odd array. Okay, and in the simple way. Matrix, we do not have nothing to do with the matrix. We are using the same loop to access the element of the matrix. So you can see it will be very easier to use. So now, as a last topic, these are the quick topics actually. Suppose the topic 3 is something like it's all about visiting each place. So you have to understand that. And we are doing it from the very starting using the same loop. I have not changed anything in the for loop. So for loop is most important always, but in matrix, it is almost fixed. I will not say in every program, but whatever programs we have done today, in all of them, I have not touched the matrix even. So you have to understand it is all about the visiting each place. If you can visit all the places of the matrix, the things will be easier. So first program now, enter elements and print the bordering elements. Bordering elements means first need to know the meaning. So in this matrix, the bordering elements are, if I want to draw, bordering elements means, okay, let me change the color. So bordering elements means these values. I do not want to print 50 and 60, which is in middle. I want to print the bordering element. So if it is somehow, if it is the requirement, so again, I have to visit all the places again. And by some condition, I will remove some value, some elements, and I will choose some elements. So, but I have to visit all the places again. So if I put the output code again into the script, so I have copied that. Let me delete all this thing. It is simply input and output. The elements are. So here now I can write the border elements are, and here before printing it normally, these two loops again will help us to visit all the places, but I will not going to print everything. I will visit to all the places, but I will put a condition like if it is the first row, I equals to 0 means first row, or if it is the last row, or if it is the first column, j equals to 0, or if it is the last column, j equals to c minus 1. So if it belongs to the first row or the last row or the first column or the last column, then only I'm going to print the element. You can see, then I'm going to print the element. If it is not, then I will just print some spaces. That's all. Let me show you. Just let me print some spaces. That's all. Okay, so I will visit each place. That's why I'm using the same loop once again. But I put some conditions, like if these conditions are satisfied, then only I'm just going to print the element. Otherwise, I will print space. So here you can see, this is the first row. This is the last row. So I will print all the elements of the first row and the last row. And this is the first column. And this is the last column, 35, 65, and 95. So it has to be on the first row or the last row or the first column or the last column. Those four conditions I have written. So if I run now, let me give something bigger, like 4 rows and 5 columns, say. So 10, 20, 30, 32, 34, suppose 4 rows, 5 columns. Next is suppose 40, 50, 60, 65, 67, something. 70, 80, 90, 93, 94. In the last row, 11, 22, 33, 44. Some arbitrary values. You can give anything. So you can see, I can print the border elements. But again, you have to visit all the places. And after that, you have to give some condition. So border elements got printed. So I think you are getting familiar with the matrix programs, and it is easier, you can find, as we do not have much things to do with the for loop. So now probably this is the last program for the day. Suppose anyone is asking for enter the elements for a square matrix and print the diagonals. So what is square matrix? Square matrix is something you have to have that idea. It is very simple, nothing major. Square matrix is easier than the normal matrix. In square matrix, you do not have different row and column. It has to be one. You will be having same row and same column. it will be like 3 by 3 or 4 by 4, something like that. So there will be no more R. You can take like N. You can take N. So the row and column will be same. So you can take like enter the size of the square matrix. You can print something like that. Enter the size and you will take it inside N. So obviously all the loops will be changed to N. There will be no row, no column. Everything will be N. So let me write N everywhere. N. Okay, everywhere I have written N. So now if it is asking for the diagonals. So diagonals, let me take it as square. So 3 rows, 3 columns. Extra column I have removed. So diagonal elements means it is looking for the elements like this. First of all, the left diagonal. So it is looking for the elements like this. So if you can remember from where we have started and from where we have written these two loops, these two loops are basically generating all the places, all the positions of the matrix. So what was the positions? These are the values. Okay, values can be 100, values can be here instead of 90, it can be 900 instead of 80, it can be 31, something, anything can be there. But the position will be always 0, 0, 0, 1. Row comes first, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, something like that. So you can see if I want to track the diagonal elements, if I want to track the pattern, here row I and j will be same during the different number generation. These two for loops will generate all the combination of the number. All these numbers you can see in my screen, all these positions will be generated by these two loops. But where the value of I will be matching with j, you can see row and column number are same. Those will be called as a diagonal. So now, if I just simply write, instead of border, I will write diagonal elements. So here I will be simply writing like when I equals to j, then I'm going to print the elements. Let me first run. Again, otherwise the loops will be same. I and j will be, the for loop of I and j will be using to generate different positions. That's all. So let me insert 3. And let me insert few values. Simple values. You can enter any values, but you can see the diagonal elements I have printed because on those positions, the value of I and j are same. That's the thing. Again, we have to visit all the places. And if I want to extract the another diagonal, the right diagonal means if I want to fetch this one. So obviously the positions will be like this. So for this new diagonal, what type of logic we can use? You can see here, nothing is getting matched. So here I can see I have to show the right diagonal as well somehow. I'm not able to find any good logic. So I have to bring something. I have to write something. Here I can see 0 plus 2 equals to 2. 1 plus 1 equals to 2. 2 plus 0 equals to 2. So the sum of this right diagonal should be 2. And I can write something like that. I can write something. It should be I plus j equals to 2. Now, from where 2 will come? It is basically 3 minus 1. That means n minus 1. Let me check if it is really happening with the size 4 as well. So a 4 size square matrix will look like something like this. 1, 0, let me write 1, 1, 1, 2, 1, 3, 2, 0, 2, 1, 2, 2, 2, 3. And here it is 3, 0, 3, 1, 3, 2, 3, 3. Let me remove this line and if I draw this line, here if you check, 0 plus 3 is 3, 1 plus 2 is 3, 2 plus 1 is 3, 3 plus 0 is 3. Why 3? Because the size of this square matrix is 4. So I can now simply, I am pretty much confident now. So I can write if I plus j becomes n minus 1, in case of a 3 size matrix, it should be 2. In case of a 4 size matrix, it should be 3. If it is satisfying I plus j equals to n minus 1, then I will get the right diagonal as well. So if I run, and if I write something like, okay, 3 size matrix, 10, 20, 30, 40, 50, 60, 70, 80, 90, then I will get both the diagonals. You can see like a Scotland flag. You can see. So now if let me test this with entering a 4 size matrix as well. So 10, 20, 30, 35, 40, 50, 60, 65, 70, 80, 90, 95. And the last one is 11, 22, 33, 44, something like that. You can see I got the diagonal elements. And you do not need to be ordered with the values. Values can be anything. Any values you can put it here. But the positions will be fixed. And that's why these two for loops are also fixed. You just need to play with the positions. Value inside doesn't matter. Okay. And these two loops are, believe me, means most efficient loops ever we are seeing. The whole chapter today, whatever we have done is dependent on these two loops. So you have to understand the meaning of these two loops. These two loops are basically as like the first program, I have without array, without matrix, I have just used these two loops to generate all the positions of the matrix. So these are being called as a position. These are not the values. These are the positions. So to generate these positions, I have used this for loop. Okay. So that's the thing. And the chapter will be easier for you, the exercise. So you can go through the exercise and you can try to solve all of the topics, all of the questions given there on the matrix. So you will be finding that chapter like front-end exercise basic, chapter probably it is 6.1. I have written it wrongly. It is not 5.1. Anyway, 6.1 matrix you will get that serially. Okay. So in case of any doubts, any problems, let me know in the comment section. And you can also contact me by my mail ID. All those things are available here as well. So yeah, it will be an easier chapter for you. Just go through that. And next day we will meet again with some tough chapters of matrix, some tough examples, some tough applications of matrix. But for the time being, it will be easier for you. Bye then.